Hey everyone, welcome back. Today we're going to be taking a look at a pretty exciting topic, and that is how to use Luma AI reality capture exports right in TouchDesigner. So if you've ever used Luma AI, you know that there are a couple different export methods that you can choose to get your scenes out of Luma. And in this tutorial, I'm going to go through how we can use each and every one of them, or at least most of them, inside of TouchDesigner with minimal intermediate steps. Most of this will be just drag and drop, so it should be very easy. And there's going to be very little programming involved with today's tutorial. So it should be great for beginners or people of all skill levels. And yeah, let's jump into things. So what we're looking at now is where we will end our sketch. I'm going to start with a couple more basic imports and then work up to this scene where we're pulling everything together. So this example file is available for my Patreons. Feel free to go and grab that. I'm going to be working through it and recreating each piece, but you can of course just go and grab this if you like. I've also included some sample assets from captures that I've taken myself. We're going to be using this one, which is from a botanical gardens, and another that I took from my local park. So with that said, we can first take a look at just the basic setup, and that will be here, where we are just using a Luma AI 360 image as an environment light. So we can jump inside, see what's going on, and I'm actually just going to delete this entire thing and recreate this from scratch. So here is what the Luma capture dashboard looks like. You can see I have a couple on this account. You can also grab other people's from the community. So for this, what we're going to want to download is simply the 360 image. And I'm using this capture, which I took of a local park. And the reason that I'm using this one right now is because this was a scene capture as opposed to an object capture. And that means that when we download this image, and then we go to import the image, here we go. We can see that it looks like a pretty completely mapped picture. Some of the object captures won't necessarily have the full image filled in. For example, if I look at this capture of a plant, we can see that this HDR map is missing some large regions, and that's because the focus of this capture and thus the Luma AI training was on an object, not on the surroundings, so we kind of lose some of that information. You can still use it. There are some artistic things to do, but if we're looking to kind of properly environment map something, we will want to use a HDR that has most of the information. You can see there's some spots missing, but that is not super important. Much better to have the most coverage, and of course you can just use your own or something else. So that is the environment map we're going to use. I'll make a null, and I'll call this just environment map. And then, very simple, we will use a box, an attribute create, geometry, drop this camera viewport onto our render. And then the last thing we need to do is add a PBR material and turn the roughness all the way down. And now we just have to add our environment light and put our environment map on it. Now I'm going to turn my render resolution way up. and give my box some rotation. And so now we can see that very simply here, we have a environment map brought into this PBR rendering pipeline. And whoops, we have this geometry that is now being lit by using our reality capture and in a PBR pipeline. So this is the most basic setup, and we can start to see here how this can be a pretty powerful technique, because once we're using environment mapping and PBR rendering pipelines, there's a ton of additional stuff that you can do. That's out of scope of this tutorial, but definitely worth some exploration on your own. So that is the very basic setup, and how we can use, as you saw, basically just a straight drag and drop for an environment map. And now we can see some nice reflections already getting mapped onto our cube. Now you'll notice that it is a little bit blurry in some points. This is a combination of the capture quality. This one I took pretty quickly. And our resolution is not terribly high for an environment map. So something to be aware of, but in many cases, I think this will still really be a great technique. And also, I personally think it lends itself to some more artistic interpretation as well, because there's a little bit more to explore. And we'll get into some of that in a little bit. So that was our basic setup. This next one is going to be very similar. The only difference here is that we are additionally using a skybox, and that skybox allows us to basically add a backdrop to our scene. So we have our 360 image that's being used as an environment map, and then we're mapping this cube based on that environment map with, again, a PBR texture. This is all exactly the same as I just did in the last talks. The only thing that we added here is this environment skybox. And so I'll recreate that skybox really quickly. And it's very simple. We are going to simply take a sphere and a null, and then a geo. And now we're going to turn this sphere, maybe using a transform. We can make this sphere much larger, like a size of 10. And the key there is that we want it bigger than our camera. And then we'll use a constant material. I'll use a select. I'll select this environment map. Then I'll use another null and drag and drop that onto my constant. And now we can see, especially if I move our camera around, that we have our skybox now as kind of like a backdrop. And the cool thing is that because we're using the same environment map for both the skybox texturing and the cube map lighting, we can see that the reflections are already starting to look pretty physically realistic. This part of the box is facing toward the ground, is reflecting the ground. This face of the box is reflecting the trees and the branches above it, and etc. And so this is a really quick way to get some much more physically realistic lighting effects and reflections in your scene, and can start to, I think, add a lot of depth to 3D renders, which is something that TouchDesigner lacks quite a lot, so any help that we can get there is going to be great. A couple other things to note. One, the reason that this environment map is mapping so well to our sphere is because Luma AI actually exports a 360 image, and that's why it looks kind of funky and warped when it is just being looked at on this texture viewer and mapped to a square. But it is then perfectly mapped to a sphere, which we can see here, and that is exactly what we want for both an environment map, so that our lighting has undistorted angles, but then also for our skybox, so that we don't have any seams or anything on our sphere. So the last thing, sometimes this is kind of up to you. You can use a blur, or really anything, but I like to use a blur sometimes on my skybox and turn it up pretty high. And this allows us to have sharp reflections on the geometry and kind of have that be the focal point, but still retaining all of that consistent color and form in the background, which adds both a cheap depth of field and also, I think, a little bit of focus and attention on your subject. So that can be nice sometimes if that's what you are interested in. So that is how to use the Luma 360 image export as both a HDR map or an HDR image for an environment map and a PBR rendering pipeline, and then also in a skybox, which you can use in conjunction for some cool effects. All right, next we're going to look at object imports. So if we go back to our Luma page, and this is how I'm going to look at my plant export, which I'll show you all, I guess, right now. So this is the plant export. This was taken at a botanical garden, and I really like this plant. So this is kind of what it looks like in the capture. And if we click on the export here, so now we're going to look at object exports. And so for that, we're going to be using the usdz and the obj. So I would download each of these right now for a capture of your choice, or you can use the assets that I have in the zip file on my Patreon. So download both of these, and I recommend starting with the low poly and then going up. The reason for that is sometimes there can be a ton of polygons depending on what you're capturing, and your computer might not be able to handle it, and it might crash. So start with the low poly and go from there. We'll take a look. Here we can see we have this import already. So I will, I think, delete all of this, and we could just start it again. So first we will just drag and drop in that import. So this is going to be the obj file, low poly. We can see here we have our low poly obj. And so here we can just drop down a geo. You can use whatever camera you like. I've been using camera viewports, but you can obviously just use your regular camera as well. You can add a light, and then we can add a render top. Whoops. Render top. Increase that resolution. See a warning, no camera comp found. That means we need to drop this camera viewport on our render. Alt-N to add a null, and then D to display it. So now we can see that we have this OBJ file brought in and rendered. This is helpful because you can use whatever material you want then on this OBJ. So we can do something very simple and just use a Phong material and get a little bit of lighting. And then something that I did on the demo that I just deleted is just use an LFO with 3 channels, say RGB, and make the frequency like 0.2, the offset 0.5, the amplitude 0.5, and the phase we'll do me dot chan index times 1.3, and that'll give us some nice little offsets for each of these channels. And then I'll add another null with Alt-N for good practice, and I can use this as my lighting, just like that. And so now we can see that we can use some different lighting. If I copy and paste this lighting, and then maybe copy and paste these LFOs, and then I'll turn this into a Gaussian, and then I'll change the phase a little bit. And then I'll drag and drop these light channels onto this new light. And then what we can do is on both of these lights, have them look at our geometry. I'm going to constrain this light to the camera and just move it a little bit. And then this light, I'm going to move around and kind of come from like the bottom. And so now we have two different color lights shining on our object and animating in real time, and we can use a transform top, then to simply throw a background on here. And the nice thing about camera viewport, we can turn on auto rotate there, and then we can have this just rotating real nice for us. You can obviously use the geocomp as the translate as well, but yeah, both options are helpful in different ways. Now we could use different materials here. For example, I bet we could use an environment light and a PBR. So I'll put that PBR on there, and we can use a movie file in. You can go grab that same environment map. And now if we turn down our roughness, we can see that we're now PBR mapping. We have a very reflective, very metallic texture on here right now, but we can start to see some of those reflections being pulled in from our environment map as well. And it looks like a cool kind of liquid crystal piece of geometry. Okay, so that is using just the OBJ import. You may notice that when you have that OBJ import, there's this textures folder that has all these textures, and we'll talk in about 30 seconds about how to actually use those. And the thing is that we are actually not going to use those textures directly. We are going to use a completely different import method, and that is going to be the other usdz. So I'm going to set up a really quick render network first so that we can see what we're looking at. And so for that, render. There are, of course, better ways to set up all of these renders, but in the interest of time and clarity, I'm just doing this. We will want a light, and I'm going to turn the dimmer on this light up to like 3. Okay, so now we can use that other import type, and that is the usdx import. So if I go to my plant, we have this usdz import that we can actually just drag and drop directly. Now, if we, on our render, point the render camera at the camera viewport and the render geometry at this geometry, we'll see that it's very zoomed in, which you can see here. But if I just go to my camera viewport and home that camera viewport, then we can start to see the full geometry. I will then simply constrain my light to my camera viewport and have it look at this geometry. And now we can really see that the geometry is textured according to the textures that the Luma AI capture actually created and put together for us. It's great that this works by just dragging and dropping into TouchDesigner, because it's really annoying to have to map out all the different UV maps with the different textures. So this is a really helpful way if you want to be able to use the geometry with the native UV mapping and texturing, which we can see. If we jump inside of this import, you can look at the materials, and we can see that there's several different materials, and each of those has a different texture associated with it. And then by looking at the node 0, we can see, it's maybe more obvious in like this one, the different geometries that have various UV maps associated with them and the corresponding materials. So this is all doable by hand, but it's not fun. And so it's pretty nice to have a drag and droppable import like that, where you can just, kind of have the geometry already colored for you right from Luma. And so that is the two best ways to use object import. The GLTF method is not supported in TouchDesigner, so you can't use that. So next we're going to look at point clouds. Point clouds are going to have several different types that we'll explore. Those types are the scene, point cloud, or full mesh PLOI file, and then the Gaussian splat as well. So you can download each of these. And again, in the assets folder that I have provided, there is in the plants folder, the full mesh, the point cloud, and the Gaussian splat files. So you can use those too if you don't want to use your own. So for this first one, I have a little talk set up so we can just look at the different types of point clouds. And actually, maybe I'll do it in the viewer here. Well, now we can jump into the component. So there's 3 different types of point clouds. We can look at those first. We have our, I'm just going to move this camera so that I can turn the camera without kind of having it be the focal point here. Okay, so we have a full mesh point cloud first. And if I just home the camera, we can see that it is pretty big. It's pretty big, but we can zoom in on kind of our region of interest. We can start to see that at the center of this point cloud, there is meaningful structure. In this case, my plants. And so that's nice. And we can kind of get a feel for like the overall texture, let's say, of this point cloud. It's not super sharp, but it's pretty cool. It's like a little bit impressionist, and I like it. A little slider for the point scale, but we probably want to keep it around 1. Now we can look at the point cloud. We'll notice the orientation has changed, but again, kind of navigating around or even homing the camera and then navigating into the point cloud lets us see a little bit more of the structure. Now this one is much cleaner, as we can tell. It's a lot tighter, but because of that, it almost looks a little bit noisier in some places. So that's just kind of good to know, because this will be good for some use cases. The full mesh might be good for other use cases. And it is worth noting that you could always use some 3D processing software like Houdini or something like that to clean these point clouds, to segment them, or even just do like a point reduction in case the point clouds are too large for your PC to handle in real time. And then last, we have the Gaussian splat. Again, I'll just home my camera and then zoom in. The Gaussian splat is kind of a mix of those last 2. This is the one that I tend to prefer. It's pretty nice. It's also the same type of format that's going to be used in like an Unreal Engine project or something like that. So it might be nice to have one-to-one consistency there. But ultimately, like I said, it's going to be up to what you're looking to do. And yeah, there's a lot of aesthetic, I think, interpretation, depending on which of these you're going to use. So I have those 3 point clouds dropped in here. That's just the Gaussian splat, the full mesh, and the point cloud. And so actually my ordering was a bit wrong. So it should be full mesh and then point cloud and then Gaussian splat. Okay, so this one's actually the Gaussian splat, the one that looks kind of the noisiest, which I guess does make more sense now that I think about it. And then we have the point cloud here, and this is, I believe, the one that is looking in between. And then we have our full mesh, which is, again, much tighter, but also a little bit more chaotic. So those are the 3 types. Apologies for that order mix-up. And now I will really quickly rebuild the point cloud rendering setup. So point cloud rendering setup is pretty easy. So first things first, we're going to use an add SOP. We're going to add a point. Then we're going to use a convert SOP. We're going to convert to particles per point. Then we're going to drop a geo. Then we're going to drop a light. I'm going to again use my camera viewport. A render, which we will use these parameters on. And then we drag our camera and our geo onto the render, use Alt-N to create a null, display it with D. Now we just need to turn on our instancing, use this position texture, which is just any of the point clouds that you imported. I'm just not going to recreate this little part. Anyway, we use that as translate, and translate with R, G, and B. Throw a transform down to add a background, and then our missing piece is a point spray matte, which when added now is fully rendering our point cloud. So this is going to be the most lightweight way to render point clouds, and it's definitely the way that I recommend. You can see we got a decent number of points here, like 3 million points being rendered in like 2 milliseconds, which is pretty good. But you should probably be careful about the number of points, because sometimes these files can get pretty large, and depending on your computer, it might be a lot. So our camera, I'll just reference these for good order. And my point cloud scale, just like that. Okay, so that is how we can import and render different point clouds from Luma. And finally, need a little out, and on my auto rotate, it's my error. The error is in the bind, I think. There we go. Okay, so yes, that is how we're going to be rendering and viewing point clouds. And then in our last section, we're going to bring it all together, and this is going to be rendering a point cloud with an HDR map, PBR rendering pipeline, and a skybox. So I have my point clouds. These are exactly the same as in the last talk, so I'm not gonna recreate those or talk about them very much. This is the point cloud renderer. So the point cloud renderer, I will talk about the changes that we made. So basically, or actually, here's what I'll do. Just delete that, copy and paste these, and then we'll just work from this talks. So the first thing that we need to do is change the rendering, and beware, this is going to take quite a bit more power, because instead of rendering 1 point for each of these, we're going to be rendering a box. So I'm going to make that box size 0.5, and then the uniform scale pretty small, 0.01. And then make sure we use an attribute create to create tangents and normals, and then we wire this in. And get rid of our add and convert SOP. And then we no longer need a point sprite, but we do need a PBR. Now we don't need a real light anymore, we need an environment light. And once again, I will use this Luma 360 as an environment map. Call it env map. Turn down the roughness most of the way. It doesn't necessarily need to be the whole way. We turn down the roughness most of the way. And so now we can start to see this coming together a little bit. We need to add our skybox. So for that, we will use a sphere and a transform, and then a geometry. Make sure we're rendering all of our geometry. Use this transform to make our sphere much larger. Use a select top to select that environment light. And then use a null, get a constant map, just like we did before. Use that as the color map, and then use the constant map as the material, matte rather, as the material for our skybox. And then optionally, we can throw in a blur on that skybox, just like that. And yes, now we are seeing kind of the beginnings of what this pipeline can look like. So we can use our skybox there. Now if you turn down the roughness even more, you can see that and the metallic up a little bit more, we can see the reflection starting to form. If we look closer as well using our camera, like really get in there, you can see perhaps making the boxes a little bit bigger might help. You can see some of these reflections coming in. And so from here, it's really a matter of kind of your personal preference. If I reset this camera, and then I'm going to turn the roughness up a little bit, the metallic down a little bit more, something like this maybe. I'm going to get rid of this other light so that we have just our environment light in here. And yeah, from here it's really kind of experimenting with the pipeline and these different parameters until you arrive at some effects that are kind of what you're looking for. I think maybe I don't want this blurred quite so much. Turn our auto rotate on. This toolbar, by the way, function store toolbar, you can get that on GitHub. It's open source. I highly recommend it. It's really nice for just kind of toggling through these things. And so, yeah, this is, again, kind of just getting started with importing these Luma AI reality captures. But this shows you how you can take a pretty full gamut of the exports from Luma AI and almost natively just drop them into TouchDesigner to really be able to use them to create some pretty great scenes. So to recap, we had our basic HDR environment map. We had our environment mapping with a skybox. We had our basic object import that we can texture with whatever we want using any material and any lighting. We have this usdz import that uses the textures that are created in the UV maps that are created by Luma during the export. I will also note here that using other types of lighting might not work because this does have materials. This does have materials that are being used, and these are PBR materials. So if you want to do any special lighting on this one, it's going to take a little bit more work. We have a point cloud scene where we can view point clouds of various types. And again, that's the Gaussian splat, the full mesh, and the point cloud. And then finally, we have our PBR rendering, which actually does look quite a bit better if we just turn up that dimmer just a little bit. So yes, hopefully that was very informative. I think there's a ton to explore here using Luma Reality Capture in a variety of ways. This is really just scratching the surface. So yeah, stay tuned. I'm probably going to do quite a bit more work on this front, and I look forward to seeing what everybody comes up with. So if you make some stuff, tag me on Instagram. Thank you all for the support. As always, it's really meaningful to me, and it lets me do some great stuff, do a lot of research. Just really can't appreciate it enough. So thank you to everyone who is supporting me on Patreon. And if those of you who are just following along on YouTube, thank you as well. You're also important. I appreciate everyone. So without further ado, I will leave things here. Until next time, goodbye.